Myself, Dr. Prashant Kumar Varthan, Professor, Department of Mechanical Engineering, GIS College of Engineering, Welding. My subject office is Advanced Welding Technology, NE 703A. Lecture number 20, Welding Metallurgy and Heat Effective Zone. Today we will discuss about the welding metallurgy and heat effective zone in welding. Welding metallurgy. Chemical reactions in welding, residual stress and distortion in welding, solidification of welding, weld microstructure, phase transformation, solidification cracking, heat effective zone, heat treatment of weld metal zone. Above metallurgical aspects related to welding processes and reactions that to avoid welding defects. Introduction. The effect of structural changes that might occur while joining two similar or dissimilar materials. Weld quality depends upon several parameters. Welding metallurgy. Selection of proper sealing medium is necessary to control various welding defects. Suitable welding process reduce residual stresses, generations, and distortions. Dimensional accuracy. Due to distortion, some dimensional accuracy may affect. Solidification mode, final microstructure of the welding joints. Microstructure for sound mechanical strength. For microstructure, we can see the in structure and the strength. Find out the strength of the material. Microstructure of the welded zone. Microstructure can be developed in the fusion zone by various grain structure control mechanisms. From a welding metallurgy standpoint, the weld consists of metal that has been melted, heat affected zone, and unaffected base metal. The metallurgy of the weld, as well as the area around it, is directly related to the composition of the base material, metal started with, and the weld metal, and mixture of melted base metal and deposited filler metal. Diffuse. Heat input, size of the hash, and the process and procedures uses. In practice, it is usually considered the area of the base metal that was not melted but was heated to the point that its microstructure and mechanical properties were altered by the welding heat. From a practical standpoint, heat effective zone depends as much on the material and its accompanying treatments as it does on temperatures and heat input. Also, keep in mind that each weld pass has its own heat effective zone. Although the weld metal from a previous pass, even though it most likely has a raised temperature. is not considered a part of the hash. The width of the hash is directly related to the heat input and adjacent the hash of the weld metal. Welding metallurgy and heat affected zone. The heat affected zone is a non-melted area of metal that has undergone changes in material properties as a result of being exposed to high temperatures. These changes in material property are usually as a result of welding or high heat cutting. The hash is the area between the weld or cut and the base parameters. Weld interface, which is also referred to as massy zone, is a narrow zone consisting of a partially melted base material, which has not gotten an opportunity for mixing. This zone separates the fusion zone and heat affected zone. Refer to a non-melted area of metal that has experienced changes in its material properties as a result of exposure to high temperatures. The alteration in material properties are usually a result of welding or high heat cutting processes. Heat affected zone. Heat affected zone or simply hash is something that occurs when metal is subject to high temperatures. Some manufacturing procedures that produce the hash are thermal cutting and welding. With thermal cutting and welding, heat energy that influences both the lifespan of the tool and the metal being cut or joined. A zone is formed between the melted metal and the unaffected base metal called heat affected zone. In this zone, the metal is not melted, but the heat has led to changes in the metal's microstructure. These changes in structure can reduce the metal's strength. The hash is identifiable by a series of brightly colored bands between the cutting, welding interface, and the unaffected base metal. The colors range from light yellow to purple as shown in the table below. It is very important that the hash accounts for reduced strength to design safe applications. The weakest section of the structure exists in the hash, heat affected zone. The structure is as strong as its weakest point. Therefore, recognizing the hash may be the difference between the success and failure of a particular part. The importance of hash is very influencing the structure of the material, structure of the construction. Heat affected zone, the creation of hash depends upon the various other factors too. The zone width depends on the amount of heat generated, the duration exposure to heat, and material thickness. Thin sheets metal heats up more quickly and therefore creates a larger heat affected zone. Metallurgically, a fusion weld consists of three major zones, namely the fusion zone, the unmelted heat affected zone, adjacent to the fusion zone, and the unaffected base metal as shown in figure. In practice, it is usually considered the area of this metal that was not melted but was heated to the point that its microstructure or mechanical properties were altered by the welding heat. This is a heat affected zone, has some maximum temperature. This is the solid weld metal deposited material. This is the maximum temperature, and this zone is a solid liquid boundary. This is the grain growth zone. This is increasing crystallized zone. This is crystallized zone, and this partially transformed zone. This is partially transformed. Tempered zone, and this is unaffected waste material. So this figure is very very important for the heat affected zone. This is solid weld metal. So maximum temperature is here. So slowly it is down. The temperature is down. This solid liquid boundary. This is the boundary. So it is next to maximum temperature. Then gain growth zone. This is gain growth zone. This is bigger gain growth. So smaller gain growth. Decreasation zone. Here the decrystallized zone. And this is partially transformed zone. And this is tempered zone. This figure shows how the heat affected zone slightly changing, and the unaffected base material is also shown. It can often be recognized by a series of brightly colored bands, also visible near welds. Colors are caused by surface oxidation and are an approximately indicator of the temperature reached by the metal. Color and temperature. Light yellow is a 290 degrees centigrade or 300 degrees light yellow. Straw yellow is 340 degrees centigrade. Yellow is a 370 degrees centigrade. Brown is a 390 degrees centigrade. Purple is a 420 degrees centigrade. Dark purple is 450 degrees centigrade. Blue is the color 540 degrees centigrade. Dark blue is a 600 degrees centigrade. These are the color in between the visible weld zone. This is fusion weld structure. This is a weld metal fusion zone. Maximum temperature is here. This is the heat affected zone. Weld interface. This is a weld interface, and this is the heat affected zone. Unaffected base metal. This is unaffected. So different zones are shown. And another figure is again structure in different zones. This is columnar gains fusion zone. The coarse grain, and this is coarse grain, which I have already shown to near weld metal. Finer grain has array. This finer grain has from weld interface, the original cold work material, cold work gain structure of different zones. This is this is we have discussed. This is columnar zone where the fusion maximum temperature is there. Fusion welding weld metal is deposited here, and this is also weld metal deposited, and the maximum temperature is here. So how the fusion zone and other zones are clearly indicated. Thermal has region. This is a fine grain structure. Fine grain has, coarse grain has, and this is heat effective zone. This portion is heat effective zone. This is weld metal, columnar, intercritical. This has and subcritical has. This is subcritical and this. So in this case, coarse grain was there, and this fine grains are there. Coarse to fine, this is a subcritical has. This is a thermal has. So it is clearly shown heat affects the material, welded material, and it has an impact in the structure. This is the weakest zone of the structure, so it has to be taken care by heat treating the material. These colors also called heat tints depends on four factors. Steel chromium content. This metal increases the material resistance to oxidation. Therefore, colors will be less intense. Oxygen level during welding, uses of protective gas and electrode coating can reduce the coloration because they partly seal metal from oxidation. The rougher the surface, the faster is oxidized, causing darker color. Forces of the heat affected zone, causes of the heat affected zone. Heat affected zone can be of varying size and strength. The extent and magnitude of the heat affected zone is inversely proportional to the thermal diffusivity and cooling rates of the material, right? Cooling rate of the material. Where thermal diffusivity is high, the material cooling rate is high, and the heat affected zone is small. Where thermal diffusivity is low, cooling rate is lower, and heat affected zone is larger. This is a This is the material deposit, weld metal deposit. This is base material. This is base material. This is the heat affected zone. This is heat affected zone. And this is fusion zone. Fusion zone. This is weld metal fusion zone. So from this figure, distinctly clear the color of the welded zone. Color of the welded zone. The extent and magnitude of property change depends primarily on base material, weld filler metal, amount and concentration of heat input by the welding process. The width of the heat exchanger is influenced by cut speed. In general, faster speed results in a smaller heat affected zone. Amperage when using plasma for a given thickness of metal, a higher amperage or consequently a faster cut speed results in a smaller heat affected zone. Types of metal being cut, increased temperature and longer cutting time will results in low heat effective zone. All thermal cutting process creates a heat effective zone in the cut metal. The amount of heat inputted by the welding process plays an important role. Oxyfuel welding uses high heat input and increase the size of gas. Laser and electron beam welding give a slightly concentrated limited amount of heat, resulting in a small heat effective. Arc welding falls between these two extremes. So fusion welding heat effective is higher than solid state welding. Changes in microstructure has. Near the fusion boundary, a coarse grain structure is formed. This increases the ductility. After the coarse grain structure, the fine grain structure is formed. It increases the strength of the material. This is a true has, and this is the welding, weld metal zone. So maximum temperature, which is supposed to be peak temperature. This is a peak temperature, and this is slowly it is down. The composite region. This is 1600 degrees centigrade. Maximum fusion. Fusion boundary. This is fusion boundary. Coarse grain supercritical. This is supercritical coarse grain. Slowly it's down up to 1200 or 1100 supercritical in coarse grain, and then fine grain supercritical 1000 to 900, 1000 to 900, and intercritical so 900 to 700 intercritical, and subcritical is 700 to 600 subcritical, and this is less than that. So this is unaffected base metal, unaffected base metal. So through the distance, this is a true hash. So from this, and this figure say percentage carbon increases. Uh, this is liquid, and this liquid is liquid austenitic. This portion is from 1100 to 900 to this is 1500, the austenitic zone, and this is liquid plus ferrous carbide, and this is ferrite plus ferrous carbide. This is from 700 to this portion. So depends on the carbon percentage. Increases, the zone is also changes. Effects of heat affected zones because of has experiences sufficient heat for a long enough period of time. The layer undergoes microstructure and property changes that differ from parent. These property changes are usually undesirable and ultimately serve as the weakest part of the component. The microstructural changes can lead to residual changes, stresses, reduce material strength, increase brittleness, and decrease resistance to corrosion and or cracking. As a result, many failures occurs in the heat affected zone area. This is the distance between the, this is the 0 point, this is minus, this is plus side, the distance from the weld center, from this is negative, one's left side, this is right side, and the hardness in because hardness, the weld zone hardness is to some extent low, but slightly heat affected zone where this is a hardness is increases due to grain growth of the structure of the metal. So if this is has and this is has, the hardness is increases, shown how the hardness increases in the heat affected zone area. Due to, obviously due to gain growth of the structure. This is in well zone, there may be flow cooling in that area, so hardness is less than the heat affected zone. Has structure. This term microstructure. This is the original base material is green portion is the original green. This portion is original base material, and this term microstructure. And this is weld area, welding melt high temperature is the. This is coarse grain area, and this is grain refining. That already we have shown earlier also. This is the scale of 10 millimeter to this 12 millimeter. From this, we can see the microstructure structure of the material. So this can be reduced by taking care from the beginning, and also taking care during the setting up of the welding, preset of the welding, electrode, temperature, etc., and the thickness of the material to be welded, and also uh, type of welding, is there. So this is the microstructure shown to you, which can be minimized by heat treatment of the material of the welding area. This conclusion: has cannot be removed by fusion welding process. Has can be reduced by solid state welding. The residual stress is formed in the weld metal. This can be removed by heat treatment, tempering. It affects the mechanical property. The microstructural changes can lead to residual stresses, reduced material strength, increased brittleness, and decreased resistance to corrosion and or cracking. As a result, many failure occurs in the has. This is the conclusion of that. So we have concluded the effect of temperature and metallurgical aspects of the welding of the welding. Some questions of the number one: which of the following gas mixture is not used in gas tungsten arc welding? Is not used in gas. So one is argon helium, argon nitrogen, argon hydrogen, argon carbon dioxide. It's not used. So argon helium is used, normally used. Argon nitrogen is not used. Argon hydrogen may be used, argon carbon dioxide may be used. So answer is B, argon nitrogen. Gas metal arc welding MIG, which of the following polarity is generally used? Direct current state polarity is generally used. Direct state polarity, direct current reverse polarity, alternative current high frequency, and all of this. These are the things. It can be, but mostly generally used is one is direct current state polarity, DC positive. So electrode negative, workpiece positive. That is DC polarity, direct current state polarity. This is the direct answer. Another question: which welding processes is used to join two thick plates in one single pass? Number one, oxyacetylene welding. B, gas tungsten arc welding. C, gas metal arc welding. D, electroslag welding. So in this case, single pass thick plate is used, that is electroslag welding. Electroslag welding is thick plate can be welded and single pass. Next question, the following welding processor is used to weld fastener to plate without drilling or punching holes. There is also the A is electroslag welding, B is the oxyacetylene welding, C is the butt welding, D is the stud welding. These are the process. Stud welding is the answer. So this is the end of this session. So reference is NPTEL, Wikipedia, BWS, American Welding Society book, handbook, textbook Production Engineering by Swadesh Kumar Singh. So we are taking from this book as a reference. So thank you very much for listening, and also we have discussed the things about the welding metallurgy as well as heat effective zone, because this is very important in welding. Thank you.